Hello and welcome to Earie's 8-Bit Workshop. I'm Earie Salmon. In the last episode we took a look at the Texas Instruments TI-99 4A, the inspiration behind this, the TI-9922. So if you haven't had a chance to watch that episode, now's a good time to go back and do it. Today we'll be bringing these boards back to life, piece by piece as we start building. I'll take you through the process of populating the PCB, soldering on the core components, and getting one step closer to powering it up. This is the 9922 board, designed by Dan Werner. It's based on the TI-99 4A, but with some clever improvements that make building it with modern components much easier. Today we're going to start with the core build on the motherboard PCB, doing sockets, passive components, power regulation and logic chips. And I'll share some tips that can make the job a whole lot easier. The bill of materials for this system is quite long with many dissimilar components, and this has made for quite a long shopping list, frustratingly requiring only one or two of each passive component values. I'll be left with a lot of leftovers from my part bin. Let's start with the power section. This board is powered by a 5 volts and plus and minus 12 volts DC, and that's managed by a standard linear regulator and some capacitors for smoothing. I like to solder the power section first so I can test voltages before risking any ICs, starting with the inductors and then moving on to the smoothing capacitors. After you put each of these components in, bend the legs out slightly to hold it in place before you solder. The 0.1 microfarad capacitors do not have polarity, however the 100 microfarad capacitors do, so double check them before you solder. Stripe goes to the negative rail. I'm using a 3 voltage power supply sourced from AliExpress. I'm not keen on hard wiring the power supply onto the motherboard, and I expect I'll swap it out for a socket at some point. Now let's move to the passive components, resistors, ceramic caps and the system clock crystal. I always install the lowest profile parts first so that they stay flat when you flip the board over. I'm using a 3D printed leg forming tool from a pattern I found on the web. It really helps bending all those resistor legs with precision, making the insertion into the board more precise. I'll put a link in the show notes. The BOM specifies two models of transistor, three TIS-92 in Q1, Q3 and Q4, and the 2N3904 in Q2. Unfortunately, after a lot of looking, I was unable to find a supplier for the TIS-92. At first glance, the specifications for both transistors are the same with the exception of the max current. I had originally decided to use 4 2N3904, but it occurred to me that Dan was probably aware of this difference and chose the TIS-92 specifically because of it. I was able to match the TIS-92 to an alternative part, the 2N2222. The problem with the 2N2222 is that there are many different manufacturers and no standard on pinout, so it's important to get the product sheet from your supplier to match the ones you purchase. As you can see here, the TIS-92 has the emitter on pin 1, but when I compare it to the product sheet for 2N2222, the emitter is on pin 3. But you need to look at the picture that shows the pinouts. If you look closely, you can see they are numbered in reverse, so the emitter is actually the same pin regardless of the numbering. So after removing the 2N3904 that I'd previously soldered into Q1, 3 and 4, I soldered in 3 2N2222. Hopefully that will do the trick. Next up, dip sockets. I socket every major chip, but especially on retro systems. Not only does it reduce heat stress, it makes it easier to debug and replace the chips later. So here's a trick. First solder two opposite corners on the IC socket first, and that holds the socket flat while you do the rest. The TMS9900 is a monster 64-pin dip package, and I've had to order dip sockets specifically for it. I might end up soldering the CPU directly on the board if it takes too long to arrive. We'll have to wait and see. I prefer not to use return pin sockets for my ICs. They might grip better, but they're a real pain to get in. Now we're on to the pin headers and jumpers. The original TI-99 4A had two male DSUB 9 sockets for the joystick and tape. The bill of materials for the 9922 specifies two female sockets. I've confirmed with Dan that this is an error on the published BOM. You need to use male sockets like the original. In order to solder the anchor joints on these DSUB 9s, I'm having to use both hot air and my soldering iron. I'd be interested to know if there's a better way. If you know of one, please leave a message in the comments below. The 9922 has two crystals, a 48 MHz and a 10.7 MHz. However, the BOM notes that is only if you're able to source a TMS9900. I could only find a 9904 ANL, so we need to swap the 48 MHz for a 12 MHz crystal. There's also a change for L1 and C2, so watch out for that if you do the same thing. One of the upgrades Dan made to the 9922 is to use SRAM instead of DRAM. That means fewer chips and no refresh logic to worry about, which simplifies the design and makes it more stable. I'm using a 32K static RAM chip here, the 62256. So far, we've completed our power section, installed our sockets, laid down our passives and dropped in our SRAM. The board is really starting to take shape, and in the next episode we'll build the keyboard, install the CPU, the video chip and do our first power on test. We'll also talk about how Dan solved the GROM chip problem and why that was a big deal. I hope you're enjoying the build. Don't forget to hit those like and subscribe buttons to follow along, and I'll be documenting every step of the way to bring this machine back to life. Let me know in the comments if you've ever built a replica TI-99 4A. Maybe you have some tips for me. Maybe you remember using it back in the day and you've got some memories to share. I'd love to hear them. Thank you for joining me on Earie's 8-Bit Workshop, and we'll see you next time. Goodbye.